All right, today we are diving into a real climate mystery, a paradox that sounds, well, it sounds completely backward. What if the very pollution we've been trying so hard to get rid of has been hiding a huge secret about global warming?
I mean, think about that for a second. What if cleaning our air is actually making climate change worse in the short term? It feels totally wrong, right? Clean air is supposed to be a win for everybody. But what if there's a catch? A really big catch that we're just now starting to understand. So, to get to the bottom of this, we first need to talk about some pretty cool atmospheric science. Let's start with the main character in our story, these tiny little particles called aerosols, and how they can literally change the color of clouds. So, what are these aerosols anyway? Well, they're just microscopic particles floating around in the air. Some are totally natural, like sea salt or desert dust, but a whole lot of them are from us, from industrial pollution, from burning fossil fuels, and up in the sky, they act like tiny little seeds, what scientists call cloud condensation nuclei. Basically, they give water vapor something to grab onto to form a cloud droplet. Okay, here's where it gets really fascinating. These pollution particles mess with clouds in two really important ways. First, you've got something called the Tomy effect. The more pollution particles you have, the more little cloud droplets you get. And a cloud with tons of small droplets is way brighter and more reflective than a cloud with fewer, bigger drops. Then there's the Albrecht effect. These tiny droplets are so small it takes them longer to clump together and fall as rain, so the clouds literally stick around for longer. The end result of all this? Brighter, longer-lasting clouds that act like giant mirrors, reflecting more sunlight back out into space, and that cools the planet down. So you can picture this as a giant climatic tug-of-war going on right above our heads. For more than a century, we've been pumping out greenhouse gases, and that's been pulling global temperatures up. But at the exact same time, all this aerosol pollution has been creating these brighter clouds, pulling in the complete opposite direction, and masking some of the warming we would have otherwise seen. Okay, so let's see how this global tug-of-war has actually played out over the last century and a half. We're going to look back in time and track this cooling effect from the very start of the industrial era. This timeline of sulfur dioxide, or SO2, that's a major source of these cooling aerosols, it really tells the story. Emissions start to creep up with the Industrial Revolution, right? Then, after World War II, they just explode. But then around 1980, something changes. Thanks to things like the Clean Air Act, emissions in the US and Europe peak and start to drop fast. But just as the West was cleaning up its act, industrialization in Asia took off, and their emissions went through the roof. The source of this cooling effect literally started shifting from one side of the planet to the other. So how much cooling are we actually talking about here? Is it a big deal? Well, according to the IPCC, the Intergovernmental Panel on Climate Change, the answer is yes. They estimate that these aerosol cloud interactions have had a significant cooling effect. Now, you can see there's a pretty wide range of uncertainty there, but the main takeaway is that this effect has been strong enough to put a real dent in the warming from greenhouse gases. And this brings us right to the heart of our story, which is a really fascinating scientific debate. We know these aerosols have been cooling the planet, but the huge question now is, have we already passed the point of peak cooling? And as we're about to see, the answer really depends on which climate model you ask. To figure all this stuff out, scientists have to use these incredibly complex computer models to simulate the entire Earth's climate. But what happens when the models don't agree? A recent NASA study ran some historical simulations and got two very, very different answers. So let's meet the two contenders. On one side, you have the matrix model. Think of this one like a super high-definition close-up lens. It's focused on the nitty-gritty physics of how individual aerosol particles grow and interact. On the other side is the OMA model. This one is more like a wide-angle lens. It's tracking the big picture, the total mass of different types of aerosols, like sulfates or dust. Just two different ways of looking at the same atmosphere. The first result from that super detailed matrix model is pretty shocking. It suggests that the maximum cooling effect from pollution didn't happen recently. It happened way back in the 1980s. That's right around when those SO2 emissions peaked in the West. And according to this model, that cooling effect has been getting weaker ever since. But then the other model, OMA, comes back with a completely different story. It says, nope, not the 80s. It finds that peak cooling happened much more recently, around 2010, mostly driven by that huge spike in pollution from Asia. And right there, that's the scientific puzzle they're trying to solve. This quote from that NASA study really hits home. Now, negative forcing is just the science speak for a cooling effect. But just think about what this means. The possibility that we passed peak cooling over 4 decades ago, that's a huge deal. It suggests that for the last 40 years, the brakes on warming have been slowly easing up, even as we've been flooring the greenhouse gas accelerator.
So at this point, you might be thinking, okay, two computer models disagree. Why should I care? Well, this isn't just some academic debate. It matters a lot. Let's break down exactly why this puzzle is so important.
You see, knowing when peak cooling happened is a critical piece of the whole climate puzzle. If cooling has really been declining since the 1980s, it could mean our climate is even more sensitive to CO2 than we realized. And as we continue to clean up our air, which, let's be clear, is absolutely vital for our health, we're basically removing this cooling mask. We're starting to reveal the full, unvarnished warming effect from all the greenhouse gases we've emitted.
And that leaves us with this final, really powerful thought. By succeeding in cleaning our air, we may have accidentally kicked off a massive, uncontrolled experiment. We are actively removing a pollutant that, for all its terrible health effects, was also providing a kind of planetary cooling service. And the question now is, what happens next? Are we ready to face the full force of the warming we've created?